Hello everyone, how are you? I hope you are all doing well. So today we will solve numericals based on the chapter moving charges and magnetism. Okay, so here one question is given as a circular coil of wire consisting of 100 turns, each of radius 8.0 centimeter carries a current of 0.40 ampere. What is the magnitude of the magnetic field B vector at the center of the coil? Okay, so as we know that for a circular wire, okay, so for a circular wire, the magnetic field at its center is given as, let me draw the diagram so we'll get the idea. This is the circular wire, and the radius of the circular wire is nothing but it is 8.0 centimeter. So it will be, okay, it is given as 0.8 centimeter, and the current which is flowing is 0.40 ampere. So let me write here the number of turns is n equals to 100 turns, and the radius is 8.0 centimeter. So it can be written as 8.0 into 10 to the power minus 2 meter. And the current which is flowing through the circular loop is I equals to 0.40 ampere. Now, as we know that the magnetic field due to a circular wire at the point which is at its center is given as, or we can say the magnetic field at the center of a circular wire is, okay, so that is basically B naught equals to mu naught Ni upon 2R. So this is the expression for magnetic field at the center of a circular wire. Now we will put the values. So what are the values here? The value of mu naught is, as we know that it is 4 pi into 10 to the power minus 7. And the value of number of turns is 100 as given. And the current is 0.40 ampere. And on in the denominator, it will be 2 into R. So value of R is 8.0 into 10 to the power minus 2. And the unit of magnetic field is Tesla. Okay. And we can write here the reason why we have taken the value of mu naught as 4 pi into 10 to the power 4. That is very obvious, but we can write here 4 pi into 10 to the power minus 7, or what will be its unit? Tesla meter, Tesla meter per ampere. This will be the unit. Now, again, come to the calculation. So what are the calculation here? B naught equals to, if there is something to cancel, then we can do that. Okay. So here if 100, here the 100 will be multiplied with 0.40, so it will become 40. So it will be 4 pi into 10 to the power minus 7 into 40 divided by, and this this 10 to the power minus 2 will go on the numerator, so it will become plus 10 to the power 2. Now it is in the denominator, it is 2 into 8 only. Okay, so now from the numerator and denominator, we can say that it is nothing but B naught equals to 4 into 4 is 16, and in the denominator also it is 2 into 8 is 16. So only pi is left. So the answer will be pi into 10 to the power, what it is, 2 and plus 1 from here. So it will be plus 3. So minus 7 plus 3 is minus 4 Tesla. So this will be the value of magnetic field at the center of the circular loop. So if you want to write the value of pi also, then it is also correct. So it will be 3.14 into 10 to the power minus 4. Wait, minus 4 Tesla. Minus 4 Tesla. This will be the answer. Okay. Let's see another question. Question number 2. In this question, they have given a long straight wire carries a current of 35 ampere. A long straight wire carries a current of carries a current of 35 ampere. What is the magnitude? The question is, what is the magnitude of the magnetic field B vector at a point 20 centimeter from the wire. 20 centimeter from the wire. So here, in case in the previous question, they have given us the circular wire, but in this question, they have given us a straight wire. So in case of a straight wire, the approach will be little different. So let me draw a straight wire here. Let's say for our example, like in this question, they have not mentioned the direction of current and the point at where they have taken like the on which side, left or right, which side we have to take the 20 centimeters. So here, as per our assumption, we can take. So here I'm assuming that the direction of current is upside and the value of current is given at it is 35 centimeter and the point is, let's say the point is here. And for example, that point is P and it is 20 centimeter. They have given us it is 20 centimeter away. Okay, so now we have to find out the magnetic field at that point P and actually the magnitude of magnetic field. So we know that the magnetic field due to a straight current carrying wire current carrying conductor or wire, whatever we can say, conductor at a distance at a distance at a distance d is it is b equals to mu naught I upon 2 pi d. This is the expression for magnetic field due to a straight conductor in which the current is flowing in some particular direction and we want to find out the magnetic field at a distance d. So here the in this case the values are given as I equals to 35 ampere and d is 20 centimeter, or we can say it will be 0.20 meter. Both are same. Now let's put the values in the equation, we will get B equals to the value of mu naught, as we know that it is 4 pi into 10 to the power minus 7, and the value of I is given as 35, and it will be 2 pi into the value of D is 0.020 meter. Now let's solve the question, and the unit, don't forget to write, it is Tesla. Now the calculation is B equals to this 2 pi, the 4 pi will be cancelled by 2 pi and we will get here 2. So it will be 2 into 10 to the power minus 7 into 35 upon 0.20 Tesla. Now this 2 and 0.20, now this 2 will be cancelled by 0.20. So it will be, what it will be? If we write here, let me write B equals to, this 2 will be cancelled out because 0.020 into 100 is, sorry, 0.20 times 10 is 2. So it will be 10 only. The upside, it will be 10 into 10 to the power minus 7 into 35 Tesla. Now, the magnetic field is very simple now. So what is left here? 10 to the power minus 7, and here it will become minus 6. And uh, if we take the decimal point after after one digit, so it will be 3.5 into 10 to the power minus 5 Tesla. So this will be the answer of the given question. Like they were asking that find out the magnetic field at some point which is 20 centimeter away from the wire, and the current was given as 35 ampere. Now let's solve another question. In this question they have given, let me write the question. That a long straight wire, a long straight wire a long straight wire in the horizontal plane in the horizontal plane carries a current of carries a current of 50 ampere 50 ampere in north to south direction. 50 ampere 50 ampere in north to south direction. Okay. And what is the magnitude and direction of the magnetic field, they are asking. The magnitude, what is the magnitude and direction of magnitude and direction of b vector at a point, b vector at a point 2.5 meter 5 meter east of the wire, east of the wire. This they are asking. Okay. So first of all, it will be very clear if we draw the diagram. So let's try to draw the diagram and then we'll see that the how easy this question is. Okay, this is the wire. This is the wire in which the current is flowing in which direction? North to south direction. That means in the downward direction. So let's draw the current here. So current is in which direction? Downward direction, like this. And they are asking us to find out the magnitude and direction of the magnetic field at a point 2.5 meter east of the wire. So at east means let's draw the that picture also, that how they are saying north, south, and we know that the coordinate system north, south, east, and west. So in the east direction at 2.5 meter, okay, they have given us a point that 2.5 meter away we have to find out. Let's say that point is P and it is 2.5 meter away. And in which direction? In east direction. Okay. Here we have to do two things. So first is the magnitude of the magnetic field. That will be very easy. In the previous question also we have solved. That is B equals to mu naught I upon 2 pi d. But how will we find out the direction of magnetic? Okay. So as we can see that it is the case of a straight conductor wire in which the current is flowing in a particular direction. So we will use right hand rule. Okay. So right hand rule. So current is in the downward direction. So our right hand thumb should be in the in the downward direction. Then at uh, at the point where like in which direction the point is taken, we have to take that. We have to determine at that particular point. We have to determine the direction of magnetic. So let's say the current is in the downward direction. So the magnetic field at that point will be P. So our curved finger is in the direction out of the page. Out of the page, or sometime it is called as vertically up, like towards me. If we draw this diagram at the page, then it will be the direction of the magnetic field will be out of the page. So, or if we say that here the in we can say in the 3D coordinate system, that is also fine. So how it will be, let's see. This is y direction, x direction, and the vertically up will be called as z direction. So that's how the coordinate system will look like. So according to this, the magnetic field will be, let me write here, magnetic field. First of all, we will determine the magnitude and then we will write the direction also. So the magnetic field, its magnitude will be B equals to mu naught I upon 2 pi d. Now we will place the values. B equals to mu naught. The value of mu naught is 4 pi into 10 to the power minus 7. And the value of I is given as 50 ampere. And the value of D is given as 2.5 meter. This time don't need to convert it into the meter because it is it is already in the meter. And the unit will be as usual Tesla. Now solve it. So we will get B equals to here we can cancel something. If we this 2 pi and 4 pi cancelled by 2. and this 2.5 will cancel 50 by 20. Okay, so we will get 2 into 20, that is 40 into 10 to the power minus 7 Tesla. So the magnetic field will be 4.0 into 10 to the power minus 7. Sorry, it will not be minus 7, it will be minus 6 because we have taken decimal after one digit. So it will be 4.0 into 10 to the power minus 6 Tesla. This will be the magnitude here. And what will be the direction, as we have already determined? The direction of the magnetic field is vertically up, or we can say out of the page. Or we can write in the vectorial form also. Vector form in vector form. So magnetic field will be B vector equals to 4.0 into 10 to the power minus 6 Tesla, and the direction is kk. Okay, so this will be the answer for this given question. So don't get confused between the direction, because whatever you are writing, you should be writing it right. Okay, so here either you have written kk, it is also right. If you are writing, okay, let me write here. If you are writing here vertically up also, that is also fine. Vertically up, that is also fine. Or if you are writing out of the page, that is also correct. And if you define here the direction of the magnetic field by the other symbols of the magnetic field, like the cross and the point symbol. So which symbol will be there here? Because it is out of the page, so the symbol will be, this symbol will be of the magnetic field. So like this, you can also determine, you can also define. I hope you understood the questions and the answers. And if you have still any, if you still have any doubt, then you can ask in the comment section. I'll be happy to answer them. Thank you.